Alright, so this is section 1.2. It's graphs of equations. There's actually a lot going on in this section, and it's really the first time in PreCalc that I think students are kind of confused. Let's start off with the easy stuff, the notes. Finding, for the most part I didn't put it up there, but it's just finding a point or testing whether a point works on the line. So that is, plug in x, see what you get for y. I'll do an example to show exactly what I mean by that. But where the notes start is finding x-intercepts, or finding intercepts in general. X-intercepts, you let y equal 0, and you solve for x. It means you get x by itself. So after you plug a 0 in for y, you solve for x, okay? The next one is to find y-intercepts. You let x equal 0, and you solve for y. Vice versa. And of course, again, I'm going to do some examples, but these are the general idea behind the notes. Next is symmetry. There's two ways to do it. One of the easier ways to do it is to test by graphing it. And one way to do it is by testing points. If you want to know if something's symmetrical across the x-axis, you're going to say, well, xy is also the point xy. So something symmetrical across the x-axis if xy and x negative y are on the same graph. Okay? And then y-axis is if xy and negative xy are on the same graph. And then finally, origin is if xy and negative x, negative y is on the same graph. So how I like to do is if they flip, and it's really easy to see if you mirror it. Again, most students have already seen this, they're just not aware of the wording behind it. Okay? The second way to find symmetry, and this is the one where students struggle the most because I think it requires more mathematical skill, I think, or understanding, and instead of just graphing it and looking at a visual, this one they have to think conceptually. The rule with algebraic symmetry is after we replace something, we need to do some math and see if it equals the original. For it to be symmetrical across something, it has to equal the original equation. So, if I say the x-axis, I replace a y with a negative y. After I do some math, and that becomes the original equation, then it's symmetrical across the x-axis. And then, for the y-axis, I replace x with negative x, do some math, and see if it's symmetrical. And the last one is origin. You replace x and y with a negative x and negative y, and go from there. Of course, I'll do some examples on this one, because this is one of the confusing parts of this section. One section is, or that I've noticed students haven't learned by the time they got to PreCalc, is the standard equation of a circle. It is x minus h squared plus y minus k squared equals r squared, where h and k are the center, and you notice how they're flipped signs here. It's the negative h here, but it's just positive h here. And then r is the radius of the circle. Students have trouble with this, okay? And they struggle because they got to remember x and y are just variables. You don't actually plug anything into them unless you want to find the radius. But in general, you want to find the center, which is h and k, and remember to flip the signs. I'll do some examples of how to find circles. I think if they can understand this easy or at the start, it will help them when they get to transformations later on in the chapter. So again, there's the notes. Let me go ahead and pause it, and I'll erase it, and then we'll start some examples. So there we go. Alright, let's get started on some examples. What we have here is check to see if those points work on the graph. So part A, and there's two parts to it. What I suggest, there's two ways to do it. You can plug in x and y, or you just plug in one of them and solve it. So for me, I like plugging in x. So what I'm going to do for part A, I'm going to come down here. Actually, let me use a different color. So let's see it. I'm going to say, alright, A, plug 2 in for x. So y equals 2 squared minus 3 times 2 plus 2, right? And then go ahead and solve for x. I'm going to see if the blue shows up on the board. Pretty good. Okay, it does. So go ahead and solve it out. We get 2 squared, it's going to be 4 minus 6 plus 2. We'll go ahead and do some math. Well, 2 plus 4, or actually go 4 minus 6 first. That's negative 2. Plus 2, so that's 0. So y equals 0. Does it work? Come back up here and check. For this one, y equals 0. So that point works. So let's try B. And I'm going to go ahead and try it up here, so I can stay out of that glare. Sorry, let me turn on the music real quick. So now, plug in negative 2 for all the x's, and let's see if we get 8 out. So we got y equals negative 2 squared minus 3 times negative 2 plus 2. So we get negative 2 squared, which is still 4 plus 6 plus 2. Alrighty, that's going to equal 12. As we see, that one doesn't work because we were supposed to get 8. So we're going to just say yes and no. So that's for those examples. That's just finding the solution. Let's just see if the solution works. All right. So let's jump on to our next example. Try to write down, we're going to do quite a bit from this one. So for 23, I'll try to stay out of that glare. Our equation is y equals 5x minus 6. So what we're trying to do on 23 is find the x and y-intercepts of the graph. Okay, so find x-intercept and y-intercept. Okay, so, and there could be multiple x-intercepts, could be multiple y-intercepts. So we'll just say in general find x-intercept and y, or x-intercepts, y-intercepts. If you remember, to find the x-intercept, we set y equal to 0. So we go, so to find the x-intercept, we go y equal, set y equal to 0, so we get 0 equals 5x minus 6, and so on for x, or get x by itself. We move the 6 over, add the 6, okay, and add that over, and then divide by 5, so x equals 5, 6. That's the x-intercept. To find y-intercept, we set x equal to 0. Let that happen, okay? So now we get y equals 5 times 0 minus 6. Well, 5 times 0 is 0, so y equals negative 6. And those are our intercepts for that problem, okay? Now, moving on to maybe a little bit challenging one, we are 31. And that one reads y squared equals 6 minus x. And again, we're trying to find x-intercepts and y-intercepts. So let's find the x-intercepts first. We can set y equal to 0. So we get 0 equals 6 minus x. Normally we move the 6 over. This time we move the x over because it's just added over. So x equals 6. So our answer would be 6, 0 for our x-intercept. Okay, I didn't put that on the last problem, but that's basically how it would look. Now let's find our y-intercept. Remember, we let x equal 0. So that means we're going to get y squared equals 6 minus 0. Can I minus 0? That just goes away. So we get y squared equals 6. But remember, we want to get y by itself. So no exponents on it, no numbers whatsoever. So we're going to take the square root. And we get y equals the square root of 6. Now, most people leave it there, and that's where people mess up. If we take the square root of something, we have to always remember it's plus or minus. Because the square gets rid of that, even if it was negative square root of 6. So if we went negative square root of 6 times negative square root of 6, we just get 6. The negatives cancel out. So this will be our other answer. So we'd write it 0 plus or minus the square root of 6. Okay? So there's various problems of finding intercepts, and that's a pretty easy concept, but can be confusing as well. Now, moving on to symmetry problems. So we're going to do 2 examples. The first one will be 33. And we want to find, so we have x squared minus y equals 0. We want to find symmetry. Okay? I do it a different way. I do it for all 3. And I highly encourage my students to do all 3 so they get more practice doing it. The first one, we want to see if it's symmetrical across the x-axis. So from the notes, and that's why I always say positive with the notes, it says plug in a negative y to see if it's symmetrical across the x-axis. Now, the notes can be confusing if you're not used to reading a math textbook, which, in general, most students don't know how to read one. So what we do, wherever we see a y, we're going to plug in and change that to a negative y. So it looks like this, x squared minus a negative y. Now, the only way to see if it's symmetrical is if it checks off and equals this equation again. It has to equal that equation. It has to look just like it. Well, let's do some math real quick. So we get x squared plus y equals 0. There's no way that does not look like this, so it's not symmetrical across the x-axis. So let's try the y-axis. This is where we plug in a negative x for all x. So we have x, change those to negative x. And we get negative x squared minus y. This is where students kind of get confused. Not just students, but this is where people get confused. The x is a variable, but I can still have to square this. And that looks like negative x times negative x. And negative x times negative x is just positive x still. So no matter what this is in here, because it's squared, it's going to turn out to be positive. So we can just write that as x squared minus y equals 0. That is the same equation as this equation. So this one works. And we're going to do all 3. The origin, okay, that's where we plug in a negative for both x and y. So x, negative x, y, negative y. Okay, so we're going to have negative x squared minus negative y equals 0. Let's go ahead and simplify it, or solve the negative dilemma we have going on. So this is x squared plus y equals 0. That also does not look like this, so does not work around the origin. Our only answer then is symmetrical across the y-axis. I highly encourage you to do all 3. That way you get practice. So let's do another example. 37. I'm just going to go ahead and leave. So we're going to do 37. Again, if you're in my class, these are examples straight from the book. So it's y equals x squared plus 1. I think it's plus 1. It is. So let's do the same thing. Find symmetry. First one, x-axis. I like to start in there anyways. So plug in a negative y. And right away I can tell that's not going to be symmetrical across it, because that negative y, if I multiply by negative 1, it changes all those. That doesn't work. So no. Y-axis. We get y equals, remember that's where we change it in negative x. Alright, so if we do some math real quick, we get it. This equals negative x squared plus 1. That negative x stays there. It does not equal the same thing, so this one does not work. Last one, origin. Remember that's a negative y. Plug in two negatives this time, negatives for x and y. And my student struggle has to go to each term, each x, okay? So we get this, which turns into that. Now, let's multiply by negative 1. And now when we multiply by negative 1, we don't have to multiply the top, because the bottom's already set. So this whole thing, so think of the negative all in front of it. So this becomes y equals x squared by 1, because what we did, and I'll write it in different colors so it stands out, we multiplied by negative 1. And they cancel out, and we get the same thing, so this one works. And that's our answer, okay? Symmetry is kind of confusing, I agree. But I think with practice and doing it over and over again, it kind of makes sense. So, the last part of the notes was circles. So let's do two examples in circles. The first example we're going to do is 71. And for the problem with circles, let's see, it gives us the center, (2, -1), and the radius of, let's see, 71, radius of 4. So, what it wants us to do is write it in standard form. If we go back, standard form of circles, x minus h squared plus y minus k squared equals r squared. Remember, our center, this is h and this is k. So just plug them in, and this is r. Plug them in. So that means x minus 2 squared plus y minus -1 squared equals 4 squared. Go ahead and simplify it. So it's going to look like x minus 2 squared plus y plus 1, squared equals 16. That's the answer. That's what they're looking for in the book. Okay. There are some other problems where they say solution point. So I'll write this down. Solution point. If you see the word circle and you have a solution point, that is a point on the circle. Okay. There's also one problem where it gives you 2 endpoints of the diameter, so find the distance between the two, that's your radius, cut it in half. Or if it says 2 endpoints of diameter, do the distance formula, cut that in half, that's your radius, then do the midpoint, and that's your center. Let's do one more example of circles, and we're going to do 81. And they actually, this time they give you the equation. They want you to tell what the center and the radius of the circle is. So this they read x minus 1/2 squared equals 9/4. So they want the center and the radius. Center's easy. This is just h and k. Well, and it's still 1/2. It's negative. Remember, if I look back over here, there's negative in front of it. That's normal, so it means I just kind of keep changing the sign. If you want to think about it that way, 1/2, 1/2. The radius is r squared. There's no square on this term. It's just 9/4. So for the radius, we have r. For the radius, we have to go 9/4. Take the square root of that. Because this is r squared, there's no squared. The square root applies to both 9 and 4. So break it up like that, and that just becomes 3/2. So there's your answers, the center and radius. Those are actually pretty simple, but students like to complicate it, things. I test center circles pretty much, so make sure, if you're in my class and you're watching this, make sure you study circles. But that's it for section 1.2. Hope this helps you with your studies.